Okay, so now we want to take a look at some vertical and horizontal stretching and compressing, some reflections. And again, we're going to go back to this model. We have g of x equal to a times some f of b times x minus c plus d, where g of x is my child and f of x is my parent function. The a is responsible for a reflection over the x-axis, and it is also responsible for vertical stretching or compressing. So as a gets to be some number bigger than 1, we are vertically stretching, and as a is some number less than 1, we are vertically compressing. Similarly, b is responsible for a reflection over the y-axis, and this time we're looking at a horizontal stretch when b is greater than 1, or excuse me, less than 1, and we're looking for a compression when b is greater than 1. So I say absolute value of a and b because the negative just tells us if we're reflecting. The numerical value tells us if we are stretching or compressing. So let's say, for example, I have the equation f of x equals x squared, which is just our standard parabola. So we have x and y, -2, -1, 0, 1, and 2. And we know that for that parent function, we have points at 4, 1, 0, 1, 4. So -2, 4, -1, 1, 0, 0. And we have a typical parabola. Okay, if I had some function that was, let's say, some 2 times x minus 1 squared, okay, now my transformations are going to be a vertical stretch by a factor of 2, and it's going to be a horizontal translation to the right 1 unit. Okay, so I'm identifying my transformations there. Now when I make my table, because it's a horizontal translation, I'm going to take my old x's and add 1 to them. Because it's a vertical stretch, I'm going to take my old y's, and a stretch is going to multiply them by 2. It's not like a translation. I'm not going to add 2. I'm really stretching them out, so I'm going to multiply. So my x's all increase by 1 from my original parent table. My y's all double. So my new graph of this child, -1, so I'm going to go up by 2's, so that's 8. So -1, 8, 0, 2, 1, 0, 2, 2, and 3, 8. And if it were on the same scale as the parent, then I would notice that it really looks stretched. Looks like it got a lot taller, much skinnier. And I also noticed that it was moved 1 unit to the right. Okay, let's try another example. Say I have some h of x, which is equal to, this time we'll go -2 times x plus 1 all squared plus 3. So my transformations this time Okay, I have no A, so I'm not going to have any vertical stretching, but my B is going to cause a reflection over the y-axis, and it's also going to cause a horizontal compression by a factor of 2, or I could say 1/2. My translation is going to be moved 1 to the left and 3 up. So when I make my table, again, I'm going to go back to my typical parent, x and y, -2, -1, 0, 1, and 2, 4, 1, 0, 1, and 4. Okay? My x's, because of horizontal change, my x's are going to be multiplied in this case, and I have to be careful, not by 2, but actually by 1/2. So I'm going to take my x's and multiply by -1/2. This is similar to when we translate, we don't translate right 1, we translate left 1. Anytime we're changing our horizontal aspect of the graph, we're always doing the opposite. So instead of adding 1, we're subtracting 1. Instead of multiplying by -2, we're multiplying by -1/2. So I'm going to multiply first, and then I'm going to subtract 1 from all of my x's. So in other words, -1/2 times my old x of -2 minus 1 gives me 1 minus 1, which is 0. The same thing for my -1. Well, that's going to give me -1/2. The same thing for my old 0, which is going to give me -1. My old 1 is going to give me -1.5, and my old 2 is going to give me -2. My y values are going to be the y's plus 3. So 7, 4, 3, 4, 7. So the transformations that affect your y values are what they are. If it's plus 3, I add 3. If I'm multiplying by 2, like the last example, I'm going to multiply by 2. But the transformations that change the x values are always a little weird. So now I'm going to go to my x and y plane. I'm going to plot 0, 7. Just enough room. -1/2, 4. -1, 3. -1.5, 4. -2, 7. I'll connect my points. So there's my parabola. And you can see that that has been compressed by a factor of 2. I pushed it in. It is skinnier. Okay? It's been moved 1 unit to the left, and it's been moved up 3 units.